Hello, we are continuing to highlight the virtual research poster competition. Joining us today is Mahmud Hasan. Hi, Mahmud.
Hi, Kyle.
So tell us a little bit about yourself.
Sure. I'm a fourth year PhD student in the Industrial and Systems Engineering department. I work in the Data Intensive Manufacturing Environment Lab, or DIME Lab for short, under the supervision of Dr. Binil Starley. A lot of the work that we do has to deal with the application of artificial intelligence and data-driven methods into making manufacturing processes more intelligent.
That's fascinating. And what was the research your poster
Yeah,
reflects?
so to start with a very short background behind the research that we did, both my advisor, Dr. Starley, and my co-advisor, Dr. Shirwaiker, for this research, both of them have been extensively involved in tissue engineering and regenerative medicine projects in the past. And what happens in most of these projects is the researchers have to grow different types of cells in culture media or culture flasks, and they have to periodically observe these flasks under microscopes to find out what type of cells are being grown in those flasks and what is their relative rate of growth or confluency. Now, most of these tasks as of now are highly manual, and hence they take a lot of time. And it becomes really difficult for beginners to discriminate between the different types of cells being grown in the culture flasks. So this is where our lab was trying to find out whether we can use artificial intelligence and computer vision techniques to automate that process and to just so that we can come up with a system where we can teach a machine to understand and identify those different types of cells. So for this, we collected around 300 images of cells grown over 2 months, and we used those images to train a deep learning model. And eventually we were able to teach a computer to identify between three types of cells, namely 3T3, MG63, and HSC cells, up to an accuracy level of around 99%. So that was a pretty good accuracy, classification accuracy that we were obtaining. At the same time, we were able to devise an algorithm based on computer vision and image processing techniques, which was able to estimate confluences of cell cultures being grown on culture media just by looking at images. And we were able to encapsulate both of the systems on a cyber infrastructure, which has the ability to allow researchers from all around the world to upload their images on a server backend, and the server would reply back to the researchers with the types or classification of the cells in the images and the estimated confluency.
That's fascinating.
Thank you.
Thank you for sharing, Mahmud.
Thanks a lot, and thanks for allowing me to talk about my research.
Yeah, take care.
You too.